Hi. So at this point, hopefully you have read the first couple pages of section 1.5, and you've gotten at least up to the coordinate formula for slope bit. And I'd like to go into this a little bit with a little bit more detail because it's a useful thing to understand, I think. It's going to come up a lot later. So where does this come from? Well, first of all, the way we started defining slope, the previous section, or the one before that, is you take your delta y over your delta x, where the delta y is how much you go up and down from one point, how far up do you go, and the delta x is from one point, how far do you go to the right to get to the other point. And what does that have to do with the coordinates? How do you get that? I'd like to explain that here in a little bit more detail, just in case you didn't really understand it in the textbook. So, uh, first of all, let's remember what coordinates mean. So, for example, if I say this coordinate here, this point here, has a y coordinate, y1, that means that's how far up you go from the x-axis to get to that point. That's this distance is y1. And likewise, this vertical distance to go from the x-axis up to this point, that's y2. So how far is it in between them? That should include all of y2, but then subtracting y1, doing it this way, gives you that distance in between. So that's why the total distance here minus the distance that you don't have gives you the change in y. Likewise, the x2 coordinate represents how far away from the y-axis this point is, or in other words, this distance from the origin over to here. The x1 coordinate represents how far the y-axis is from this point, which is the same as from the origin to this point on the x-axis. So if you want to know what is the horizontal distance between them, it's just going to be this total distance x2 minus what you don't have, the x1. That leaves you with the distance between them. And that all works well in this kind of setup where the x2 is greater than the x1 and the y2 is greater than the y1, and both of these numbers come out positive. It's a little bit harder to understand if you have something different like this situation here, where you might have a decreasing line where it's going to end up having a negative slope, and it depends on how you label the points. Here's point number 1 and point number 2. You can do it backwards like that. It should still give you the same thing. The formula should still work. The only difference is, like in this case, if you do x2 is this distance here, if you do that distance minus the x1 distance, you're going to get a negative thing. The formula should still work. It's still going to give you the same slope as if you think about it another way. Hopefully, when you do it this way, the answer comes out to be negative. But that's a tricky thing to understand. This is a little bit more advanced about why it still works when you have the negative numbers, but it might be fun to think about. Okay, now let's go on to the next example I'd like to talk about. Now's a good place to pause it yourself to read it, and if you're copying down the problems, you can copy this one down. And now that you've had a moment to read it, let's talk about how we can approach the problem. So what it says is find the slope. So you probably want to write down the formula for slope. I got the color a little bit mixed up there. And except the difference is, in this case, we don't have the variable y and the variable x. Here, instead of y, it's w. That represents the millions of cases of wine that people have had in a certain year. And instead of x, we've got time. Which represents, it looks like the t variable here represents the number of years after 1990. Because the first point they're talking about is when t is 3 here, excuse me. So at that point there, let's look at what is the amount of wine that people had then. Looks like they had 188.6 million cases. At that time. And there's a little decimal in there you can't see. Okay, and then the other point they tell you about is at this point, this represents when t here is, it looks like about 13 there. And at that point, oops, what is W at that point? 258.3 million cases of wine. So to find the slope of this, we can get the delta W. So let's make this be part A here. The change in W is going to be this distance here, which is going to be 258.3 minus 188.6 million cases of wine, divided by the change in T, which we can do with subtraction here. This one's a little easier. It's just 13 minus 3. And then you can plug that into a calculator and see what it comes out to be. Here's this row right here is what it would look like. And it comes out to 6.97 if you want to do it all in one row. So the slope of the graph is that, and that's what part A is asking for. We should probably include the units of this, because the units are always going to be whatever the units of the top of it was, which are the units of y, or w in this case. And here, these must represent millions of cases of wine. And the units of the denominator are going to be whatever the units of the t-axis or the x-axis are, which in this case is, well, that represents 13 years after 1990, 3 years after 1990. That's going to be years. So now for B, to interpret that as a rate of change, to state it as a rate of change, what does it tell you in this problem? You should probably write a complete sentence. And what I would say in this case is it tells you about the constant rate that wine consumption is increasing here. It's going up over time. Every time 1 year goes by, it's going up by about this much is one way to write it. You can always think of the slope as what is the delta W if delta T is 1. That's how much it's going up by each year. You could also think of it as just a rate of change, writing it out like the wine consumption increased by 6.97 million cases per year. Means exactly like so. Except, of course, on your handwriting, you're writing your I's a little bit more neatly. Okay, there we go. So let's go on to another couple of examples in this in the next video.